Welcome back to Further Solutions Academy. Further Solutions Academy. Just encourage us more. Help us to share our videos, and anywhere you see it, help us to subscribe on it. Help us to subscribe. Just press on your subscribe button. Presently, we have over 200 videos on our platform. It means you are good to go on any topic of your choice. Just come here, any exam you want to write, come and play around. You surely get it. You have no problem. We are more of a mathematics and physics, and anything you need, just come around. You get it right. If you want to support us, we need your help at this moment. Please just support us. We need to buy data. We need to buy more data, larger board, and also better camera. You can meet us on this line 2348034495990. With this number, you can call us and you can WhatsApp us. Also, Telegram is allowed. We are all about it. You can use to reach us. Please, you can do that for us. Please, we need your help. In this video, I'll be working on work energy and power. Work energy and power. It means we have worked on work energy and power before, just to show one or two more examples of them and brief it, summarize the whole stuff. Now let me start from work. When we are talking about work, you have to understand what is called force. Force is the most important thing at this point, and we have been talking about force, weight, and I see there was one of my videos I was working on speed, energy. I was having a problem on work energy and power. Problem of speed, velocity, and acceleration, and momentum. Now I've told you that my work is always equals to mass times acceleration. I've told you, and there was a time I was talking about tension. My T, my weight, and my force. They have the same, they are all in Newton, which I've told you earlier, they are all in Newton. Now, this one, tension, weight, and force. I've told you earlier that this one is mA, while this one is mg. Now, it means these two, they are along with what? Gravitational force. And I've told you that my gravitational force is always equals to 10 meters per second squared, or 9.8. Normally, this is standard way of it. 9.8 meters per second squared. This is standard wave, approximately equals to this. And also, okay, now that is, please understand, I'm just trying to brief on that part, which is very, very important. Now, at this point, I'll be working on energy, work energy and power. Thank God my colleague have worked on it earlier, which he has given you the definition of work energy and power. Now, we'll start from normally. What is the formula of work energy and power? If I should define work energy and power, it's just like it's defined as the product of force and the distance. That is the simple definition of work. The simple definition is product of what? Force and what? And distance. Now, if there is no any distance, there is no work done. There must be a force and there must be a distance. Now, that is just be very, very understand that. It means my work done, we call it work done. Let me put work done. Okay, my work done, let me put it work equals to force multiplied by distance. Is distance or displacement. Let me put it displacement. Force multiplied by what? Displacement. Which my force is Newton, and this one is always what? Distance is what? Meter. Which is, I can also say that my work done can also be equals to what? Force times what? X. Forget this one. Force times distance. Now, which is Newton meter. That is Newton meter. Very, very important. And okay, without going far, that is what I'm here for. That is what I'm here for. Just to put more example, more light on this part. Now, I want to work on a problem, which is if the force applied is at an angle 2. I don't like, let me cut this into 2. At an angle theta to the horizontal. The work done depends on what direction the object moves. Now, in a normal way, I will have something like this, my force, and now I've told you earlier, this is my vertical component, this is my what? Horizontal component, which is x and y axis. We all know that. Now, let's assume I have this. This is my theta. This is my theta. We have done, when we are doing our coplanar forces, and we have done a lot of things on this, how to resolve it, which you all understand that. Here, we always call it what? F cos theta. And here, which is also the same thing as here, we call it what? F sine theta. F sine theta. Now, for us to move on to this, we can say that what? Please, I want to chip in some things that let me put on to efficiency. My efficiency, which is my F, is always equals to what? Okay, let me not talk about efficiency now. Okay, let me just hold on to efficiency. Let me first try to explain power before I explain that. Now, okay, with this, we are good to go. We are good to go. We are good to go. And also, okay, I think we are good to go. Now, if the bus moves in the horizontal, horizontal direction, the work done W is equals to force cos theta multiplied by distance, or mg cos theta multiplied by what? Multiplied by distance. Now we know what mg is, which is force, and also if the bus moves in the vertical direction, the work done W is equals to Wf sine theta, which is multiplied by what? Distance. Multiplied by distance. This is my distance, so I just put it as x. Please take note of that. Now, which also the same thing as equals to what? Mg sine theta multiplied by what? X. Please take note of that. Take note of that. Very, very important. We all know that my m is mass, and my g is what? Gravity. My g is gravity, and let me use acceleration due to gravity. Acceleration due to gravity. Okay. Also, now what again we need to know? My S is distant. Please take note that my S is distant. That is very, very important. Now, I think with this, you are good to go on our work energy and power. We all know that force and now the SI unit of work, it is measured. Work is measured by joule. Don't forget that. Work is measured by joule, which is J. Don't forget that. Very, very important. Now, with this, I think I've done very brief out what work is all about. Please take note of that. They are very, very. My colleague have explained the other part of it when there is on the plane, which is first that you can view that video. Is very, very good for you. And let me try to work bits on the energy. Energy. Now, when we talk about energy, we all know that energy is a very, okay, energy we all know from basically at the beginning of our life, we have been hearing the word energy. Energy is capacity or enablement or grace to do work, anyhow you want it. Just like energy is ability to do work, I just want to. Now, energy is ability or capacity or whatever you call it to do work. That is very, very important. Now, if I should define energy, my colleague have defined. I don't need to explain myself, but I will be working alongside with we have forms of energy. Energy is very deep anyway. For those in field of engineering, we do more of that. But we are, normally when we talk about energy, we have, it can never be destroyed, but you can renew energy. It's renewable. You can renew your energy, but you can't destroy it. Which me, I'm not in that line. I'll be working on kinetic energy and potential energy. Kinetic energy and potential energy. Now, when we talk about kinetic energy, which is kinetic energy. Now, I will also be working on potential energy. Potential energy. Now, I have these two things to work on. Now, when we talk about kinetic energy, we have potential energy and kinetic energy. My kinetic energy, it means the body is at what? It has moved. Normally, in our practical, we use what is called pendulum. This is a pendulum. At this point, is in potential. But when that thing is moving. When it's moving, is in kinetic. Please take note of that. This is potential. At rest and at move. I don't have much to say. Let me quickly move on to educational part of it. Don't worry. Very soon, we need your support so that you can have a set up our lab and have it very well and utilize well. Now, when we hear what kinetic energy, my kinetic energy, we'll always call it I've explained that when it's at move, which is my kinetic energy, it always equals to 1/2 mv squared. Which this one is mass, this one is velocity. Velocity, which is squared, velocity squared. Now, when we talk about my mass is always in kg. My velocity is always equals to, is always in meter per seconds. Meter per seconds, we all know that. Okay, when we talk about potential energy, my potential energy is always at rest. It means I'll be talking about mgh. H is the height. H is the height. Your H will always appear as a distance. Please don't forget that. As a distance. This one is the mass. Why this one is gravity? Acceleration due to gravity. Please take note of that. Acceleration due to gravity. And I don't have much to say there. They are both of them and joke. They are both of them. Energy is more than this, but I will be giving out some problems soon so that we can see how energy is, how to approach it in any given exam. It can be JAM, it can be anywhere, That is what I would say on that part anymore. Okay, let me move on to potential energy. If I'm still with time, Okay, potential energy. I mean, the last one, which is power. Now, when we talk about power, power is a mixture of there must be force, there must be distance, and there must be time. There must be force, there must be distance, and there must be. Now, it means at the rate of time. Anytime you are working any form of problem in mathematics or physics, you have a rate. Rate means in ratio of time. Do you get it now? In ratio of time. Please don't forget that. Rate is always t. Rate is always t raised to power minus 1. That is, anytime you hear a word rate, at the rate of, it means inverse of t, inverse of time. Please take note of that. That is why when you want to define your speed, you will hear a word distant move with the rate of what? At the rate of what? With the rate of time. You know, velocity is emptying, and so on and so forth. Now, when you hear a word power, note that power is always work done with respect of what? Time taking, which is t. Work done with respect of what? It means my power is always equals to W all over T, which normally, mathematically, I have it this way. Now, when you have it that way, we all know that, let me try to simplify it for them. My power also equals to force multiplied by all over what? T. What am I doing? My work done is equals to force times distance, which is also, I can move it at mg all over what? Now, which also I can say that what? M multiplied by x all over t, all over g. Yes. What am I doing? Now, oh, sorry, okay, all over t. Now, I can also move it as mg and multiply by x all over t, which I also move it to what? mgv, because this one is velocity. Now, all this can happen. It means something can be missing. Maybe your force is missing, you are given power, you are given time, and you are given distance. It means you can generate it with this. Now, this is how power can come. Power can come in any form of this. That is why you always encounter power problem in any exam. Because of what? It's easy to form and easy to generate question on them. You know, that is just power itself. Now, that is just it. Now, let's move on. Now, okay, I think with this, we have done. Okay, I'm not talking about something on this power. It means I want to let you know that power is measured. Power is measured in joule per seconds. Joule per seconds. I've told you that because joule is the work done. This is joule. This is what? Seconds. Please ignore that. Joule per seconds. That is my power. In mathematics, I want to write it normal way. It means I'll be talking about what? Js per seconds. This is seconds, which is very, very important. Or you use the word watts. Watts, which is W. Okay, I would like to join you explaining kilowatts, and okay, maybe one of my questions will direct me to that part. Okay, with this, I think you are good to go on what? Work. Only on power. This is very important. Anytime you are solving any problem, physics, mathematics, learn to put your words, the unit on it. SI unit means standard unit. Put your second standard unit on it. It's very, very important. Okay, and we have. Okay, if I have 1 hour power pH, it means I have 7,600 watts, which is something as equals to 74,000, which is something as what? Which is something as 0.674 kilos. Please take note of that. I will explain that better soon, not now. Soon. Let me use the word soon. Please, soon is not defined anyway. If I use the word soon, maybe now or it may be after the video. Okay. Now, let me show one or two problems on what I've been explaining since, just to explain, to modify my explanation. Okay, let me start. Okay, before we move on, let me use a word efficiency. Please, it's another problem that any student, UTME student normally encounter. UTME efficiency. Efficiency of a machine. We are talking about power anyway. Now, it means, what I mean there is that my efficiency equals to power output multiplied by power input multiplied by 100, which is mathematically I can turn it to P naught multiplied by P1 multiplied by 100. Multiplied by 100. Please take note of that. My P, which is a power output, which is P naught, it can be equals to how do I say? Okay, mass. What that is mine. You can call it weight or whatever, or force, anyhow you want it. Multiplied by distance divided by what? Time. Divided by time. It means this himself is what? Is power. This power output himself, we call it what? Power. Just power. Why? Because of what? We are talking about what? Force times what? Distance all over time. Now, and also we all know that okay, P naught, P1, which is power, let me use the word power. Power input, which is P naught, equals to, my P naught is always equals to power power output multiplied by efficiency. Multiplied by efficiency. Please, please, for those that are writing exam, what is WAEC, what is Becker, you have to meet this. You can't do without this, please. These statements I list out there, they are very, very important. Please, for those that are writing all these exams, Becker, WAEC, UTME, etc., etc., please take note of this, as this part is very, very important. Okay, with this, I think let me try to show examples on these parts, so that you can understand it and be okay with it. Anyway. Thank you, Jesus. Now, where should I start from? Okay, let me start from number one. I think let me start somewhere and get somewhere. I have a question here. A boy drag a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle 60 degrees to the floor. The work done after a distance of 3 meters is okay. This is a very simple question that I'm looking at here that you are to work on. Now, please learn how to interpret question, because if you cannot interpret question, there's no way, there's no doubt of it, you may not be able to get physics problem done. It's very, very important. Now, look at this question. The question lies here. The work done after a distance of 3 meters. It means you are looking for what? Work done. Take note of that. Now, all this above, from here to here, they are just explaining, modify the what? The question. A boy drags a bag of rice along a what? Smooth horizontal floor with a force of 2 Newton. Now it means your force is here, and it's telling us how the boy is being done. How he's doing it. Now apply at a what? At an angle of what? This is the angle. Now these are just modifying the question. Why this is where the question comes from. And also, don't be confused. You have to calm down when you're solving physics problem. It's very, very, very what? Important. It's very important. Now, how do I solve physics question? Now you have to get it right. The first thing, you know what your force is saying, 2 Newton. The second thing, you know what your theta is saying, 60 degrees. The third thing, you need your what? Your distance, which is what? 3 meters. With this, we are talking about work done. My work done, which is my work done, equals to force multiplied by what? Distance. Oh, let me write it finish. Distance. Which my work done can be equals to force multiplied by what? My distance is what? Okay, let me just, my force multiplied by what? X, which is Newton and X anyway. Okay, force, which is, I can say it mg, because it's gravity. This time around, the boy is dragging. As it's dragging, it means we're not talking about acceleration at this point. We're talking about gravitational force acting on the bag of rice, which is that is why I'll be using G. And this time around, we are talking about what? It attached to angle. Because of angle, I must think towards at the beginning of the what? Of my class, when I was explaining vertical and what? Horizontal, which are the resolved part of it. Now, I've done that earlier. It means my W, which is my work done, it will be equals to, now how is he applying it? Horizontal floor with a force of what? This. Horizontal floor, I've told you earlier that we have this and we have this. And this one is what? Force cos theta. Now, it means my horizontal component is there. This is my vertical component, which is force multiplied by what? Sine theta. Now, this is applied now. It means I can say that what? My force, which is my mg cos theta multiplied by distance. Now, this one is force. I don't need to use mg, because force is already on the question. Now, W equals to, what is my force? 2 cos 60 multiplied by, what is my distance? My distance is what? 3, which is 3 meters. Now, we all know, I've told you earlier, when I was explaining trade, that learn to use this, or you use your fingerprint. This is special angle, which is sine 60. I've told you that 0, 30, 45, 60, and 90. Now, 0, 1, 2, 3, 4. 4, 4, 4, 4, 4. It's a special angle. We're talking about what? Cos 60. My cos 60, this is what? Sine is moving this way. My cos will move this way. Which I'm explaining that my cos, my sine theta, is always equals to what? Cos 90 minus theta. Please, you have to understand this part Okay, it means this is my what? This one will be what? 90, 60, 45, 90. I mean 30 and 0 and 0. Now, root of this number is equals to what? 1 all over 2. 2, 1 all over 2. I'm just rooting this. If you want to learn more about this, you can go to our trigonometry. We have explained it. This will cancel this. It means my work done, it will be equals to what? 3 joule. My work done is equals to what? 3 joule. Please, 3 joule will explain difference between 3 meter and what? 3 joule. This is meter. This is what? Distance. This is what? Work. This is work. Okay. I think it's like half time. Okay. I won't go more on this now. Be expecting more video on this part, and make sure you watch the next video, which is I will show more examples on this part. Thanks for watching. Okay, before we leave there, don't forget we are on with further solutions academy. Encourage us more to share. If you have not, I suppose to subscribe. If you have not subscribed before, press on your subscribe button. Don't forget to subscribe. And also, if you want to help us, we need many things at this period. We need to set up our lab, have a good laboratory, so that as we are talking about this, we'll be showing you a lab. Please 2348034495990. With this number, for any contribution, you can call us, you can reach us, you can WhatsApp us. The address questions. WhatsApp. You can also Telegram is allowed. Any of them. Once again, thanks for watching.